Hello everyone, welcome to the lecture on 555 timer, which is one of the most commonly used integrated circuit. Almost a billion 555 timers are produced and used worldwide every year. As the name indicates, it's a timer circuit. 555 is its identification number and also indicates the three resistance inside the transistor, which are of 5 kilo ohm each. You can use 555 timer to call it as having three resistances of 5 kilo ohm each. So we have 8 pins, dual inline package. There is a notch. Every IC integrated circuit has a notch. It is used for identifying which is the upper part, which is the lower part, and how the pins are counted. Pins are also counted as starting from left 1 2 3 4, then bottom up 5 6 7 8. Okay, so we have 8 pins for the 555 timer. 555 timer is used for generating timing pulses and frequencies where it is not a critical requirement to have accurate results. 555 timer has many states of operation. Three major types of operation being astable, monostable, and bistable. Okay, based on the application, we can use one of these states. Astable is the simplest, bistable is the most complex. Okay, so what we will do is we'll learn is oscillator creation using 555 timer, using IC 555 timer. Okay, also we'll implement this on our every circuit app so that we can play with the resistances, capacitances, and observe the variation in the signals. Before starting with the design of oscillator, we'll see the pins. 1 and 8 pins, ground, VCC. 4 is reset, like reset in any other IC. It will reset the working to the design part, means back to 0. Then we have 3 output, means where we are collecting the output of the timer. 2 is the trigger signal. As the name indicates, it triggers the output to go low. I'll mention these. Trigger pin, it makes the output go low if it detects a voltage of 1 by 3 VCC. Why 1 by 3? Because we have 3 resistances, so we have voltage divided as 1/3, 1/3, 1/3. So we'll use 1/3 here and a reference 2/3 for control voltage. The control pin by default has control of 2/3 voltage. Control means this is the reference point, but we can change this reference by applying an external source. Threshold is the opposite of trigger signal. In the threshold part, if 2/3 VCC is observed, output is driven high. Opposite work. The one left is discharge. Discharge pin, this is for voltage discharge through the capacitor, so that we can recreate the operation of pulses, timing pulses. Okay, so we'll start with our oscillator design. How to design is, major part is keeping VCC on the 8th pin and ground on the first pin. Next is on 3, we are going to get the voltage output. Call this as voltage. A reset pin, if it is made 0, the timer will reset, so we don't want that to happen. So we'll keep the reset pin 4 to VCC, and 7, the discharging voltage happens through R1 and a timing capacitor C. This VC is given to 6th pin and 2nd pin. These are our reference resistances R1, R2. The 5th pin will have a comparator capacitor of 0.01 microfarad. Okay, we will not bother about the capacitor. We'll see the simple operation of this circuit. Many different things are here. So what happens is, the capacitor charges, we'll call this as T high, through R1, R2. So we'll have a pulse T high as 0.693 R1, R2 multiplied by C. RC we know, 0.693 times R1 plus R2 into C. T low is the discharging part of the capacitor, which happens to through only R2. Means 7th pin declares when the capacitor should discharge. Okay, observe carefully. 7th pin declares when the capacitor should discharge. So 0.693 times R2 C. So our output duty cycle, or also called as on and off period, is given by T high. This is a standard number, T high, standard equation, plus T low. We'll take an example. Say this is our low time, this is our high time, this will be our period. Duty cycle for this signal will be 50%, indicating that 50% high, 50% low. Total time divided by how much time it is high, that will be our duty cycle. Frequency we know, this is given by the total time, T high plus T low. Means one cycle, how much time it is going to take. If we make an inverse, that is the frequency of our cycle. So this is how we'll use 555 timer to design an oscillator. A careful observation of how this is going to happen. We'll observe the voltages. We'll observe the voltages on the capacitor when it reaches 2/3 VCC and when it reaches 1/3 VCC. We'll take few lengths of signal. Say capacitor charges, discharges, because R1 and R2 are used, charging time takes longer, discharging happens fast, charge, discharge. Okay, so we are taking the reference of how much capacitor is charged. We call this as VC. So when we have signal above 1/3 VC, the output pulse, this is our output signal, the output signal starts rising. It rises, keeps there until capacitor reaches 2/3 voltage, which tells the signal to go low. Again on 1/3 VCC, go high, go low, high, low, high, low, so on. So this is how we are going to generate the pulses. Very important part is how the capacitor charges and discharges. In the same way, the output signals are pulsated. So very interesting circuit. We'll implement this using our every circuit app. Until then, all the best, happy learning.